We're going to start learning about factoring quadratics, and this is where we really start bringing together a lot of the skills that we've been learning with FOIL and such. And I just want to start off with a review of FOIL because it's really going to lead us into what we do. Let's say that if I was multiplying these two binomials, we'll do an easy one. X plus 3 times x plus 4. And I was going to use FOIL. Well, we multiply the first terms together. X times x is x squared. We multiply the outside terms together and we get plus 4x. Multiply the inside terms together, plus 3x. And then we multiply the last terms together and we get plus 12. And what we get is x squared plus 7x plus 12. All right. And as we know, these two middle terms right here combine to make this last middle term. And this is why if you look at the title of today's lesson, I put quadratics are in the form x squared plus bx plus c. But I didn't put a letter in front of the x squared. This number for all the ones that we're going to do today is going to be equal to 1. Just like the one that I did down here. All right. We're not going to have anything today that is going to have anything other than just a blank right here, which means the number is 1. Now, what I want to show you is that today we're going to be given this right here. We're going to be given the quadratic in that form, and we're going to factor it back into this form. And it's really just a matter of getting our number combinations together, all right? And the way we're going to do this, I'm going to actually work backwards on this problem right here and show you how we're going to do it. We're going to use what's called a factor sum table. And what we want is we want to multiply two things together and get this 12. So see this 12 right here? I'm going to put it up here, positive 12, like that. If you look at the way that we do FOIL, don't I get the last terms by multiplying the 3 times the 4? All right. The sum is we want the right combination that will give us a sum of 7. Now, I'm going to start off with some possibilities that aren't the answer just to illustrate. Couldn't I multiply 2 and 6 together to get 12? I could. But when I add the 2 and the 6 together, 2 plus 6 is 8, and that is not what we want, so I'm going to put a frowny face right there like that. This is not the combination that we want. Couldn't I do 12 times 1? Don't forget that one. Some of the problems you're going to do tonight, it might be this combination where you do 1 times the number. Well, 12 times 1 makes our 12, but what's 1 plus 12? 13. That is not what we want either. How about the one that you know works, 3 and 4? Well, 3 times 4 is 12. And 3 plus 4 is 7, and that is most definitely the one that we want. Once you identify these two numbers, 3 and 4, all you got to do is put it back in to our binomials. It's very simple. I'm going to put an x there and an x there. And then whatever these two numbers are, I put them in. 3, 4, and since they were both positive, I put pluses on both. And there we go. We have factored it. We have went backwards from this expression to my two binomials. So obviously we've got some more problems we need to do to get used to this. We will call these examples now. And I'll go ahead and call this one example number 2 since I've kind of already done one. So let's say that we had x squared plus 9x plus 20. Now, if you're watching this on YouTube, I recommend you pause the video and try this one on your own. All right. So we make our factor sum table. And by the way, after you get used to this, you can just put an F and an S. All right. And so I want these things this time to multiply to be positive 20. And my sum that I want is positive 9. All right. So once again, I think you probably know what the answer is, but let me start with one that's not the answer. How about 2 times 10? Well, 2 times 10 is 20, right? But 2 plus 10 is 12. Frowny face. So I think by now you're probably sure that it's 4 and 5. 4 times 5 is 20. 4 plus 5 is 9. There we go. That's what we want. So this quadratic, this is called a quadratic, factors into x plus 4 and x plus 5. All right. Now, all the problems we've done so far have been nice, simple, all pluses. Let's do one now where the middle term is a negative. And let's just think about this for a minute. All right. When this thing factors, of course, I'm going to have an x and an x. And we're still going to use our factor sum table. But before we do that, I just wanted to explain to you that because this thing is a minus in the middle, and this is a plus, we have to think a little bit. Remember how we get this 12. It's multiplying the last terms together. The only way that I could get a plus and this be negative is if both of these both the numbers were negatives. Do you agree? Isn't a negative times a negative a positive? It is. So when you're doing your combinations over here, I want to get a positive 12. And I want the numbers to combine to be negative 8. We need to use two negative numbers. All right. So if I use negative 3 and negative 4, negative 3 times negative 4 gives me my positive 12. But negative 3 plus negative 4 is negative 7. That doesn't work. So let's try negative 2 and negative 6. Well, negative 2 times negative 6 makes 12. And negative 2 plus negative 6 makes negative 8. That's what we want. So this one is x minus 2 and x minus 6. And you can always double check these by doing FOIL. If you're not sure if you got the right answer, try it doing FOIL. All right. All right, now another situation you have not seen yet is one where the C term, the last term is negative. X squared plus 2x minus 15. So once again, we'll make a factor sum table. But this time, I am trying to get a negative 15, and the numbers need to add up to be positive 2. Now let's think for just a minute. If I'm going to multiply two numbers together and get a negative, don't I have to have one positive and one negative? All right. So let's say that I tried negative 5 and positive 3. Negative 5 times positive 3 makes negative 15. But negative 5 plus 3 is negative 2. I need a positive 2. All right. So let's flip it around. Let's do -3 and +5. -3 times +5 makes -15. And -3 plus 5 is +2. That's the one that we want. This one up here was a frowny face. So this one factors into x minus 3 times x plus 5. All right. Now, one of the other things that's going to happen tonight is they're going to ask you to solve one of these quadratics. All right. What happens if they tell you to solve? Well, here's the good news. Nothing changes yet. All right. Nothing changes. Let me show you what I mean. Let's say that we had x squared minus 2x minus 35 equals 0. And they told you to solve it. Well, guess what? Everything starts the same way. Okay? I'm going to make a factor sum table. I want two numbers that multiply to get -35, but combined to be -2. So once again, I need a positive and a negative number. All right. And how about -7 and +5? -7 times +5 is -35. And -7 plus 5 is -2. Hey, we got it on the first try that time. So this factors into x minus 7 times x plus 5 equals 0. Now, what if we're told to solve this? It's very easy because of something called the zero product property. The zero product property says that if I have something times something equals 0, that I can place each of those factors equal to 0 and solve them separately, like that. Turn it into two little simple equations. This is very simple algebra, as you know. We'll add 7 to both sides. One of the answers is 7. The other problem, we subtract 5, we subtract 5. 0 minus 5 is -5. So the other answer is -5. And you have just solved your first quadratic equation. All right. Now what we find is that because this power of the quadratic is 2, I can have up to 2 answers like we did here. And what do these answers mean graphically? This is the other thing I'm going to have you do when you solve these. The graph of a quadratic is nothing more than a U-shaped feature called a parabola. And these two answers right here are the x-intercepts. It's very easy. So -5, +7 are the intercepts. 2, 3, 4, 5, 6, 7. Those are the intercepts. And the parabola is I'm going to try to do this with my pen. My pen's a little bit hard to do curves. That, and it's normally prettier than that, I apologize, but it's just basically a U, more like that, all right, that goes through those two x-intercepts. And you've just solved your first quadratic equation. So you do everything the same that we did on the first few problems. You just set up these two little simple algebra problems equal to 0 and solve them. Now we're just about done. I just want to show you a couple of special situations and how to handle them. What if they told you to solve Let's see, which example is this? We'll call this example 5. What if they told you to solve one and it looked a little weird like this? They told you to solve that one. Well, if you'll notice something, it looks different than the one we just did. Look at the one we just did. It was equal to 0. We have to have it equal to 0 to solve it. So all I need to do to start this problem is do a very simple algebra step and take this term over here using algebra. Let's just add 6x to both sides. And that's going to fix it. Because on the right-hand side, negative 6x plus 6x is 0. And on the left-hand side, I've now got my quadratic. I'm going to write it in the correct order. X squared plus 6x minus 27. You do want to write it in that order. The squared term, then the x term, then the number. And then we would just come over to the side. We'd do our factor sum table, and we would roll with it. I need two things that make negative 27 combined to be positive 6. Let's see, how about negative 9, positive 3? Well, those combine to be negative 6, so let's just flip our answers around. Let's make this a positive 9, negative 3. There we go. There's my positive 6. So this thing factors into x plus 9, x minus 3. I can split this into my two little equations, x plus 9 equals 0, and x minus 3 equals 0, and solve those two simple little algebra equations. So one of the answers is negative 9. This one, of course, is going to be positive 3. And when we get ready to graph this thing, those are the intercepts. I do want you to graph the ones that you solve tonight so that you can see the idea. 1, 2, 3 is there. Negative 9 is over here. And then my U-shaped parabola goes through those two intercepts, like so. All right. So make sure that you put your quadratics in this order right here. All right. Because if they give you something like this, we're not doing an entire another problem, but they might give you one to factor or solve written like this. 21 minus 22m plus m squared. And it might totally throw you off. And you're like, well, how do I factor that? Well, write it in the correct order. The m squared goes first, then the minus 22m, and the 21 at the end. And since that's a positive 21, I write plus 21. Now, I want you to look at this problem. Do you remember how I told you that sometimes you need to use the factors 1 in the number? What's 1 times 21? 21. What's 1 plus 21? 22. All right. That's going to happen every once in a while where you use the most obvious combination. All right. To get the answer. All right. Great job today. And thank you for joining us. And we are going to stop there. And hopefully that helps you get started with quadratics.